This is our final presentation on Wikipedia traversals. The project goals of this project are to build subgraphs out of Wikipedia connection data, find the shortest path between two Wikipedia pages using source and destination pairs provided by the Wikipedia game, also known as wikiracing, and find what pages occur together usually using a strongly connected component algorithm.
Now I'll be outlining our development timeline in 4 segments. First, we had to think about what data we wanted to use and how we would procure it. While there were several publicly available data sets on what we wanted, they were either too big to process in a good manner or not labeled by name, which was kind of the point of the project. So we decided to create our own Python scripts to crawl the web using Beautiful Soup and use BFS to build our own subgraphs. And we can specify a breadth and a depth and a starting node so we get exactly what data we want. The second step was storing this data. So we wrote methods called parse from file, and this would take the CSV formatted as source pages to a destination pages and store that as a graph as an adjacency list. And next we had to actually implement the algorithms, and we decided on Dijkstra's for shortest path and a strongly connected algorithm because it fit the project very well. Finally, we wrote unit tests using the Catch2 framework and also tried using the whole system on an actual Wikipedia game session, which didn't work as well as we would have liked, but we'll talk about that later.
So one of the things that the learnings and future improvements, we want to run data procuring scripts on the cloud and save the data to a server instead of locally. What we realized was that scraping our data would take way too long locally, and each page would take nearly a second. And if we wanted to get to a slightly more complex depth or breadth, the time that it would take would nearly double or triple. So doing procuring on the servers would allow to generate more data and increase the scope of source and destination pages that we can use. Our graph was stored as an adjacency list, and we would like to in the future add a visualization script so we can animate the graph and display the shortest path. And lastly, we can add more test cases for better testing of overall functionality. We did test each method quite extensively, but we can always add more test cases. So in conclusion, a fun fact that we found was that our breadth first search always seemed to go through the Buddhism or philosophy pages, even if the start pages had 0 or remotely no obvious connections. And so hence we could see that maybe a long enough breadth first search on any start page would eventually reach the philosophy pages.
Yeah, and here are just some screenshots of our results. This is trying to find the shortest path between University of Illinois and the United States. It might not be the absolute shortest path because our breadth that we set in the data generation script might not have been high enough, but it did work. And you can see the output of our strongly connected components algorithm at the bottom. But yeah, for more details, please look at results.md file on our repository.
Thank you.